A solenoid carrying a current of 10 amps produces a magnetic field of 6 times 10 to the power of negative 4 Tesla. If the current was doubled to 20 amps and the number of turns per unit length remained the same, what would the resulting magnetic field strength be? So I'm going to write down the formula for finding magnetic field strength of the solenoid, which is going to be equal to mu naught N times I divided by L. Mu naught is constant, which is 4 pi times 10 to the power of negative 7. N is number of turns, I is electric current, and L is the length of solenoid. So in this case, B originally was 6 times 10 to the power of negative 4 Tesla. It says if we keep N over L constant and we double the electric current, what happens to the magnetic field strength? Obviously 10 becomes 20, so that's double, so magnetic field strength is going to be double as well. So we don't need to go through the whole calculation, it's going to be extra effort. So that's going to be 2 times 6 times 10 to the power of negative 4, which will be 6 times 2, 12 times 10 to the power of negative 4, or if we need to report it as 1.2 times 10 to the power of negative 3 Tesla. Now, part B. If the current was half to 5 amp and the number of turns per unit length remained the same, what would be resulting magnetic field strength be? So again, in this example, I becomes half. So we divided I by 2. So again, we are using the same formula. I becomes half, so B becomes half as well. So we divided by 2. So that will be 3 times 10 to the power of negative 4 Tesla. C. If the current is doubled to 20 amps and the number of turns per unit length double, what would the resulting magnetic field strength be? So in this case, I becomes double, from 10 becomes 20, and also number of turns per length is going to be doubled as well. So as you see here, magnetic field strength is directly proportional to electric current, and it is also directly proportional to number of turns divided by length. So I becomes double, N divided by L is double, so 2 times 2 is going to be 4. So B will be 4 times the original magnetic field strength. 6 times 4, 24. We have 2.4 times 10 to the power of negative 3. We don't need to use the calculator. D. If the current is halved, it means that from 10 to 5. And the number of turns per unit length were halved as well, what would the resulting magnetic field strength be? So I becomes half, N divided by L half as well. So it means that B becomes 1/4. So we need to have 6 times 10 to the power of negative 4 divided by 4. 6 divided by 4 is going to be 3 divided by 2, which is 1.5. Again, you don't need to use the calculator. That makes it much faster and more effective. So that's going to be the magnitude of magnetic field strength for 4 different cases.